Even David Lake is presently remotely. Okay. Start. Should we start? Hello, everyone. Welcome to the DMM working group. I'm Sri Gundavalli.
Satoru Matsushima from SoftBank.
Okay. So, few things. Please be aware of the IPR policy. When starting a presentation, you must say if there's an IPR associated with your draft. A few other considerations. Please understand the IETF requirements around this. And this is a note well statement. Please go through this, right? And do not forget, we are here for one and only one thing, for building a better internet. In that spirit, we operate. So we need a note taker. Okay, thank you, Tianji.
Okay. You can help.
Thank you, John. Okay, we have this is what we have on the agenda. The first thing is the mobility over transport network slicing for 5G. We are in the final stages. There are a few edits. We'll review them today. Followed by, these are all the topics that we have today on the agenda. We'll finally, at the conclusion, one final topic on 6G related discussions. We also have some 3GPP leads here. Yeah, we'll discuss that later. But so first, with that, John, you can give an update on. Okay. Which one? Okay.
Okay. Will you control the slides?
Yeah. Or if you can, is there no? I think I'll control.
I can.
Oh, you can control. That's good.
If I think you have to grant me
You
permission.
have to close the sharing.
Close sharing. Stop sharing.
Can you hear me? Oh, I see. I can hear the.
Okay.
I don't think it's working.
Yeah. Go ahead.
Okay. Okay. So this is the mobility aware transport network slicing for 5G, and it's in pretty good shape right now. I think we made one change, and then some related chapters on that. So I'll go through the changes that were made since the last time. So next slide. I can't control it.
Yeah. This is good.
Okay. So yeah, I'm going to turn around a little bit to.
You can take the mic. Pull out the mic. Yeah.
Okay.
But maybe.
Yeah,
So
I'll
we
stay
have to be
here
on
so
the video.
that. Yeah.
Yeah.
Okay. So the view on the left side shows the changes that we've made. And the only change really is to move from using an EP transport based interface in 3GPP to using ACAS, which is defined in T's. ACAS meaning the Attachment Circuit as a Service. So that resulted in having to put a new chapter in there about the attachment circuits with the extensions for GTP. So essentially at the bottom, I've given the kind of revisions we made. EP transport revision to use ACAS and the corresponding GTP extensions for that. Other than that, we got some very good reviews, input from the T side. Lewis has given me significant input on how they're going to implement it, and also reviews on the draft to use some of the T's work in terms of references, things like what about slicing, so that we don't have similar but duplicate references. So all of that has been corrected and revised in the draft. But the significant change is to the ACAS, and I'll go over that in the next few slides. So this is here just to let you know that the whole slicing structure that we had described is exactly as in 3GPP and nothing has changed in here. So I just go to the next page. Okay, again, here's what we had before and I'll get to what we changed. If you look over towards the left, there's the logic interface type under an EP transport. That would require changes or rather 3GPP to adopt that and agree to use UDP source port. But we don't need that now because we're using the ACAS GTP. Okay, so here's how we do this. The revisions in 28.541 now, give attribute properties called connection point info. You can see that on the middle towards the right. And that in turn references to the attachment circuit. And the attachment circuit itself is defined in T's. So that's the sequence that we're using to make the change. Next page. Okay. So if you remember, the logic interface type and so on is now taken out as a necessary part for this, and instead we're using the connection point ID type that will refer to an attachment circuit, and that attachment circuit is giving the source port equals some value, and that source port will be what the provider edge router is going to use to classify the slice. So that's really the change that has been made. The result of that is that we've had to add a couple of Yang models that extend to support GTP. On the next page. So So what you see on the right figure is the whole model with the attachment circuit, the IETF attachment circuit common, and all other structures that help to define the attachment circuit itself. What was missing is the GTP itself, and that's what's added under layer 3 service, and then below that, a layer 3 tunnel service. And the layer 3 tunnel service is referring to the GTP extensions that we have. More details on the next page. So you can see the layer 3 service, and then you can use the layer 3 tunnel service referring to the port range or port number or port range, and then an encapsulated GTP. So the L3 tunnel service and an encapsulated GTP. The L3 tunnel service itself would be used if we were to have either GTP or an IPsec ESP in UDP. And if that whole connection itself were encapsulated, for example, going between data centers using VXLAN or Geneva or something, that's what is referred to in the NCAP GTP. So the structure is added in here and complements what has been already defined in the AC service. This has been reviewed, but I would encourage this group also to have a look and see if it satisfies our requirement. I've posted it to both T's and Ops for reviews when we have gotten some very detailed reviews and suggested changes. So we've already made that here. I think that's basically what we have. The next page. Yeah, that's what we have. The major change is to use the ACAS. It, as far as we know now, it complements perfectly with what ACAS has been defined in T's. Um, so this makes it pretty complete, and we don't have any dependency anymore on having 3GPP to work on it. So I think this draft pending reviews should be ready to progress from the author's point of view.
Okay, thank you, John. Any questions, comments, TNG?
John, I think on one slide you mentioned the mapping like from the NSSAI. I thought it's like a S dash NSSAI. Can you go that one?
Yeah.
I think
You
it has
mean
to
the
be S.
single? Yeah.
Yeah, it has to be subscriber based S dash NSSAI. Normally it has to be no, not this. No, there's a one slot. Yeah, it's on the left and the middle box. Sorry, on the right middle box, the NSSAI. Normally it's S dash NSSAI, right? For the control plane configuration. So far is,
If I see on the EP transport, it is S dash NSSAI,
but here it's showing as NSSAI. Yeah, yeah. No, no, no. The above the 3GPP CP configuration. So is that what?
that should be correct because
That's
when in the beginning there are a list of NSSAIs,
okay. So it's like
out of which the
the,
system, that's what is signaled in the PD session setup. You have B, C, and so on, and then you pick a single S NSSAI. I mean, that's the S NSSAI.
okay.
Out of the B, C, and whatever else, what was picked in this case was B
Okay,
zero
yeah,
zero
I
zero.
will check it. But if you're talking about the PDO session setup, it is S dash NSI plus DNN.
Yeah, yeah, yeah.
So
That
it's
that's what is in the.
the second.
Yeah,
Okay, sure. Thank you.
yeah, but please do check. Yeah.
Any other questions on this mapping? So John, this was reviewed by TIS working group, and they agreed this is the right.
I wouldn't say T's working group, but
Yeah.
Med, who's the author of the ACAS structure. I mean that I showed
Yeah.
you. So he recommended. I mean, since GTP is not an IETF protocol,
Mhm.
that was not covered in the fundamental structure. And what they had was layer 2 bearers, but in this case, it's a layer 3 bearer with GTP. So that was the extension that was needed, and we used the format that was suggested by them.
So you talked about VXLAN. Can you just clarify? I was slightly confused. VXLAN are other, you referred to other tunneling
Right,
protocols. Can you
right.
help me understand
Okay.
the structure?
Yeah, the structure would be something like you have a tunnel in a tunnel. The
Yeah.
GTP itself is
Yeah,
a UDP
exactly. Yeah.
encapsulated tunnel, which may be aggregated and sent
Through
in
another
a
tunnel.
VXLAN or Geneve tunnel.
So the transport type can be any of the tunnel in that case,
Right,
right? Yeah,
right,
okay.
right.
Okay.
And what we've put in the draft is that that outer tunnel should have the source port copied.
Okay.
So that's the same mechanism as we had before, but now we've covered all the cases. Yeah.
One clarification. So this model seems the configuration model, right?
It is.
And this configuration model be installed in GNOB and UPF. Is that correct?
Yes.
Okay.
John, what are the next steps? What do we?
At this point, I think the draft is in pretty good shape. It's got a thorough review from Med, so that it's updated to sync up as well as possible with T's. So now we have no duplicate definitions of what is slicing or how it is used and all of that. It lines up with the work and it's complementary. So at this point, I think I'd like to get reviews from DMM,
Okay.
and
So before we wrap up the work, maybe can someone sign up to and volunteer to provide some review feedback? Anyone? TNG or close to? Okay. Thank you.
thanks, Lion.
2 weeks maybe.
Thanks, Lionel.
Any other?
Yeah. I think it's be some sort of the extended work compared to the beginning of this draft. So I only expected that the P router only be impacted to see the GTP source address, but the range of the model extended to the GNODB and UPS side. So we need to be carefully um, review the impact on the other side of the network.
May I comment on just that? Um, if you go to that slide, just the previous slide, 3GPP has accepted the AC model. So, they would support this, I would expect, but yeah, but please review. I think when we're ready to, I mean, if this looks okay to the group, yeah, we should let 3GPP know that we have this.
So any view from the 3GPP folks, Lionel or others? Okay, okay, we'll take it in our group. Oh, please.
Just a clarification on this. This is already present in the 3GPP specs. This comes from a liaison statement from, well, for contributions from a participant in the Oran Alliance that face the same problem of slicing. So from those that we were working on Oran Alliance, introduced this change request to the 3GPP spec. So it's now in the 3GPP spec.
Yeah.
So we are closing somehow the loop.
Yeah, thanks for that clarification. No, we just want to make sure we are not, we are aligned with what it's on the other side. Yeah. Okay. Thank you so much,
Thank you.
John. Next, what do we have? This one?
No, TNG map evolution. This one.
Yes, good morning, everyone. Oh yes, this I don't know how many times we have presented this one. Before the meeting, I like a couple weeks back, and then I sent a summary email based on what we have. I can go to next. Yeah, just the next,
Yeah,
and then yeah, a summary about the why we are here, because this is just a recapture of what have been done and achieved since the first adoption call. That was like exactly 1 year back. And since then has been three IETF meetings and some email alias discussions. So about 1 month back, October 11th, we sent a summary email to the alias. That was a long email, and thank you, Mr. Chair, and then for reviewing. And then after that, I replied a little bit late because I was in another 3GPP meeting in India. So I did reply, but I did not. I have to acknowledge I did not reply on time. So about 1 month, 1 week before the meeting, I say, okay, well, since we have solicited continued discussion, can we start the second adoption call? Because it's been 1 year since the last. We have done quite a few common revisions, achievements, something. So today I'm here just, I did not prepare any fancy slides, just try to summarize in the next couple of slides. That is copied from the email we have put on the alias. Uh, no, here, well, I'm not going to go through the details here. It's just the first one to answer the question. This question is from the first call, and also we have answered something. The first call was like 1 year back. This is regarding the some comments delegates have concern about inconsistent control plane discussions, and then we replies with our arguments, and then acknowledge there are some important things regarding the CP, and then why we mentioned about the CP and the UP in the draft here. So I'm not going to go through the details. This one is on the alias already. Yeah. And by the way, we discussed this in the previous two IETF meetings.
So TNG, for each of the issues, can you say whether your fix was agreed upon by the?
Yeah. The thing is like, oh, I have to look at this. Sorry about
Yeah.
that. Yeah, yeah. So the things like just to say, okay, we say, the fix is the CP inconsistency. Actually, the things like we do not have the control plane inconsistency. It just No, this one does not display. Right. Yeah. Yeah. So this um it's just to say, okay, we did originally in the draft about the UP and the CP, but it's they all center around the a new part. So it's I there's no inconsistency on this side. So it's like uh, yeah, this is the first. But the next one is more uh, yeah, this one is more crowded because we want to propose something like integrated Genobi and UPF. We call the a loop, and then the comments is regarding since you have already proposed this one, but you are still talking about SMF and 4 AMF and 2, all kind of things that might be dependent, that actually depend on the disaggregated part. So the here, the answer or the reply is we want to make this one crystal clear. Is we will not do the work, the 3GPP work in IETF, but in order to demonstrate or explain our idea here, we have to give comparison or explanation about what a 5G system is like. So that is the thing. Okay, and then for some actions, where couple of revisions since last year here, remove the some part that is going to cause some confusion, and then some very 3GPP specific things that being removed, and add some things to show, this ANOOP is a very good like something or a direction or a scheme for a specific scenario, some good scenario to justify the feasibility of the ANU part, and then revise the satellite things because a satellite is some good scenario to apply this type of the ANU part, and then yes, there's some others are just the details. Yeah, next one. The next is the adoption call from the IETF 120, and also Mr. Chair asked about because we said consensus, and then at that moment we had a extensive discussion about the consensus, and also on the email alias. For the email I put like 1 month back regarding this, and also Mr. Chair asked a question, and then I replied. So for this consensus concern, I we believe we have reached the consensus about what is the consensus here. So it's just like okay, there I think there's no misunderstanding or gap here. So yeah. Oh, thank you. Yeah, yeah, thank you. So next, I think there's one more comment just regarding the subtle demarcation between the IETF and the 3GPP. So this is a comment I think from John. Yeah, is regarding okay, what kind of the battery reference could this one deliver or give to the 3GPP? How this one might be useful to the ongoing 6G revolution part? This is just one of the possible numerous proposals. The 6G just around the corner. The first 6G stage one has been approved 2 months back to start the 6G study. This is just a possible reference design, and then focusing on the integrating the transport functionalities for both the A and the access network and the core network here. And then at least here it just give one example. Oh yeah, I'm almost done now. Yeah, yeah, this is just the final comments. Yeah, the final comment number 4 here. Well, just to say, okay, well, one of the possible, proposals we believe it does have its merit here. So the integrated A loop has the potential to offer the transport related adversary reference to the 6G and the 3GP evolution. Yeah, next. I think this is the next one. Just the conclusion about okay, what is the target of the draft? It's targeting for the 6G because just mentioned about it just around the corner, and then going to start it, and then yeah, Yeah, that's it. By the way, we're going to emphasize this is just to emphasize the work from the IETF and wireline background, not going to step into the 3GP territory. It's just as the advisory reference for 3GPP 6G evolution later. Thank you.
Thank you, Tianji. Any questions, comments? Satoru-san.
Let me clarify my comment about the consensus and running code. So as I pointed out, the, the text described about the CGPP control plane was incorrect in your previous draft. So then I need to clarify which the draft be proposed in right understanding of CGPP control plane. So that's the reason why I asked the running code, because the running code proves the right understanding about the spec and the protocol. So that's the reason. But you just get it out with that text. So now you are not appeal to the NUP is not implementable. So that will be fine, and it's not require running code.
Thank you.
Okay. So, Tianji, I think when we issued the last call, right,
Yes.
many we were tracking around 5 or 6 issues. Do you think all those issues are resolved? Did you work with
Yes,
okay.
the four major well, the first three comments
Mhm.
were from the first call, and then the final, the number four, is from I think from John K. Probably 1 or 2 meetings back. Yeah.
Okay. So again, any last opportunity? You think anyone who provided feedback, you think your issues are still there or it's resolved? John, maybe, yeah.
Yeah, I would say that there's a significant change, to um, address those issues, but the structure of the document still has things like, without changing 3GPP architecture, or this is not an attempt to do 3GPP work. Um, I'm not saying that it shouldn't progress. I mean, independent of that, I think we should adjust it so that it says what exactly this does and not what it does not do.
Okay. Yeah. Okay.
But
Yeah.
but I think the main point is okay.
Okay. Sure. Thank you.
So another question about the structure of the document. You have the mainly two part of the section. One is analysis about the current IETF DMM proposed solution, and the other is the ANUP proposal. So which one you wait for the, on with this draft?
Yeah, of course, the second part, because this is targeted for the 6G evolution. For to give the analysis on the first part, it's just to lay the foundation so that we can analyze for the second part.
Okay, so in that case, I think the analyst, the front part of the analysis seems to bias by your specific proposal. I think it would be better to split your draft with the by analyst part and the specific solution proposal part. That would
Oh,
be a one way.
okay. Yeah, we can work on that part, but the thing still, I want to lay some foundations so that when people read the draft, they at least no need to reference some other specification in order to fully understand this. So that's I can we can reduce the first part, but I still have to use the first part to lay the foundation for the second part. Yeah.
Oh, I think the first part of the document doesn't justify the needs of the ANUP.
Um. Okay. Yeah. I think we can discuss that
Okay.
part. Yeah.
Then
Yeah, take the comments. So.
Yeah, Lionel, thank you. Um, I tend to have the same kind of comments. So I've been reviewed last week the draft, and actually there is a mix between what it is already covered in 5G. So it is not intended to change anything to the 5G system for sure.
Yeah.
We have also the comparison with what was done with MUP, and MUP was based on the fact that nothing was so the 5G system or the mobile system was not impacted by the use of SFV6 below. So saying that the principle defined in 5G apply also in MUP. And here with ANUP, you are changing some basic working assumption saying, like, for instance, you introduce the fact that you would like to have a UPF closer to the access network, which means that the main purpose of the system will not to provide will be not to provide tunneling solution with a centralized UPF, but more to have something that you would be able to switch from one end to an end more easily, right? So I think this will have impact from a core network point of view, and especially the way the FMF SMF was defined, because the SMF was defined to have a centralized PCF. From my point of view, it's not an issue in your drafts, but I think we need to be clear on what it is required from a control network point of view if you want to be able to have um, um, an efficient solution to handle the mobility or the session mobility between the distributed UPF. And I think it's where it's difficult to find today in the draft um, uh, what is really required from the control plane. So we don't have to define, from my point of view, the architecture of the control plane and how the control plane will work, but what is required from the control plane to ensure that you will be able to efficiently move one session from one distributed UPF to another one.
Yeah, that is a good question. Actually, in the second comments there, that's why we removed there the handover part, because that is but handover there's a huge section about how it's supposed to be done in the 5G the spec, and then the things like this is something we want to focus on the transport with the A-loop architecture things, and then as we keep emphasizing, we don't want to step into the 3GPP part, you know otherwise, if we try to like consider all kind of like AMF, SMF, all the control planes in how it's going to provision, it's going to, I think the draft is going to explode to I don't know how many pages. So that is
I fully understand, but I think that we may also assume that people reading the document
yeah.
will know what's happened or what would happen from the access network point of view. So you don't have to describe the end of a case, but for sure, the UE will go from one access network to another access network, and we need to address this, as you said in your slide, and for that, from a UP point of view, from a user plane point of view, we should be able to describe at least what is the information that are needed from the control plane to be able to set up
Okay.
the session or to hand over the session, I would say.
Okay. Yeah, that is the things like if we try to stick to what the 5G the interaction between the control plane and the user plane of the 5G here, and then going to have well, I forget how many steps, probably 7 or 8 steps, well, if we count, well, based on how the PDO session is set up here. But for the future, if we integrate the A loop or the GNOB and the UPF together here, there are two things. If the integration can be, it's just like running VMs, but a standalone or separated VMs on the same the server. In that case, there are no significant change. But here, if we integrate them together, it's like a single standalone VM. In that case, it's going to impact the control plane part. But we do not target for the 5G things. This is for the 6G. The
But
6G is still evolves. It's going to evolve.
so TNG, one
Yeah.
comment is, I think Lionel's feedback is right. I think if
Yeah.
you
What,
if
what
you
is the
collapse such functions, you still need to define internal interfaces, keep a proper boundary,
yeah,
right?
I know
If you
that.
say everything is in one thing and we don't care about how it's,
Of
I think
course, I understand the things. I
yeah.
try to answer the question. Is like it's a big topic on that. Yeah, and hand over. Actually, we removed that part in the regarding the comment number 2, because it's going to cut some more open door for more discussions for that part. So we try to reduce the contents of the draft, make it more simplified a little
Okay.
bit. Yeah.
Okay,
So
so we'll take this
yeah,
offline.
yeah, yeah.
I
Keep
think
the
from
offline.
our point of view, I think if we can resolve these issues, we can go for a adoption call. But we have to satisfy, make sure
Yeah, I'm
these
going to.
comments, these three comments or issues are resolved,
Sure, sure.
and we can go for a LC.
Yeah, yeah,
But
sure. I'm
only
going
after
to.
resolving those issues
Yeah,
to
yeah,
their
yeah,
satisfaction. Yeah.
yeah. Sure. Thank
Okay.
you.
Thank you. Yeah. Next is. Okay.
Okay. Satoru from SoftBank, chair hat of. I present map architecture for DMM. This is the 01 version. Actually, the previous draft be superseded by this draft. So please, next slide. So I want to introduce the what the map architecture is. So here's a recap. So one is independent from specific mobile service architecture like 4G, 5G, or 6E, or PMIP or something. The map is consumable by any mobile service architecture. And second point is pluggable user frame part of mobile service architecture. So map can be coexist with genuine user plane defined in each mobile service architecture. The last point is it's independent from specific data plane protocol. Map can be implemented with any data plane protocol, and SRv6 map is a map architecture implementation by using SRv6. So then GDP SRv6 translation behavior set defined in RFC 9433 is one of the options. Okay, so please, next slide. So this is the fancy picture to show the map characteristic. We have 3 points. One is the map enable us to deploy end-to-end network slicing without hassle because the map controller can transform the session information to routing information. So then routing information easily be mapped to the slicing in the transport network. And also it can involve the MEC server instance and servers. That's the reason. And second point is optimal data path for MEC. So it's routing solution. So routing is usual for any server's deployment. So then the server side can attach to the slice with the mobile customer route. The last one is optimal data path for device to device. So it's a little bit different terminology from the CGPP defined device to device, but in this context, device to device be able to provide through the MAP-P router, not through the access network only. It's happened on the transport network. Okay, next slide, please. So this is the overview for map architecture with CPP 5G over SRv6 implementation, for example. On the left-hand side, you can see control plane using BGP. So on top of that, session information input into map controller. Then the controller transforms that session information to routing information. That routing information has two types. One is type 1 for UE, type 2 for uplink. And that route be advertised and received at the PE router. Left-hand side PE router facing the mobile service system with the genuine user plane protocol. So in this case, it be a GTP, and that GTP packet be transformed statelessly or statefully. So that packet traverse SRv6 network and then communicate with the right-hand side P to connect it to the DN side. So each P advertise the discovery route. One is interwork segment route for advertising the existing mobile service network exists, and the other side is direct segment connected to the internet or data network. Right-hand side, you can see data plane overview. So the operator builds the one SRv6 network. That one SRv6 network can host the both N6 and L3 VPN. In addition to that, that buff also supports the UPF connectivity reach to the each of the side of the mobile service network N3 and N6. So data plane view the packet traverse just go through the SR-basics only, not to touch to the UPF. But UPF still has a role to support the mobile service system. So we have to keep functionality of the UPF. Okay. Next slide, please. So this is the architecture principle. Number one. Number one is segment. So defined in map architecture. So the map architecture abstracts the mobile network as a segment. So one is interwork segment, and other is direct segment. That's me semantics I explained in using the previous slide.
Oh, it's okay.
Unmuted.
Yeah.
Okay. Oh. Okay. So many of you see the segment. It's stand on the concept of this segment routing architecture, but in the context of the map, the segment is defined only in map architecture. It's kind of the um, coincident. So as same as the many other protocol, like Ethernet has a segment, and pseudo-IA has a concept of segment, EVPN as well, and segment routing architecture is obvious. And network slicing also has a concept of segment. So we have our own semantics for segment defined in map architecture. Okay. So then it's a map is the segment routing independent and from the data plane, any of the data plane protocol independent. So the second principle is map segment auto discovery. The map segment be advertised by a map PE to be discovered by the other side of the PE. So it makes easy to find the connectivity for the session transport route advertised from the map controller based on the session. Okay. The map auto discovery route be associated with any of the data plane specific information like tunnel and cap attribute defined in the BGP. So once the any type of the tunnel type attached to the discovery route, the map can support that data plane protocol. Next slide, please. Next slide, please. Okay. So this is what we have in IANA. We have a bunch of the tunneling protocol. So those tunnel type be attached to the BGP, map segment discovery route. You can pick any protocol from that list. If you don't see your preference, you can propose that your protocol gets the code point. Okay. The third principle is the transform session to routing to leverage data plane protocol to optimize the data path for DMM. So session transform route described in section 6, map controller advertised following session transport route. One is type 1 route, ST1, we call, and the other type is ST2. So auto discovery route should be used to resolve reachability for the session transport route. ST route should be data plane independent as well, because the data plane specific information be attached to the segment discovery route, not to depend on what the session transport route advertised. Okay. Next slide, please. So this is just a reminder. We defined the map requirement, DMM requirement in RFC 7333. You can see the requirements defined in that RFC. I will skip that each requirement, but map architecture followed those requirements to fulfill. Okay, next slide, please. So this is the a slide to show the map running code available, and interoperability is secured by hackathon event in last year. So we have some map implementation by vendors, CAS and Cisco, and other open source project already implement map, especially for BGP map surfing. Okay, next slide, please. And also the running code is available to show what the map enable. So if you are interested in, so please ask me. I can show you that demo working. Okay. So this is the one slide to show the highlight of the update from previous revision. So I made some clarification on session transport route, what the session is. We clarified the session is assuming session information for a UE or MN include a pair of endpoint between the entity of user mobile user plane that we see what the session information is. And the other update is ST1, ST2 route and map extended community semantics to be clear. So the update is BGP MPNLI attribute with the nature of tunnel endpoint based packet handling. That's the ST2. The type 2 session transport route with a direct segment extended community to indicate corresponding direct segment and tunnel decapsulation. That's the clarification of the semantics for ST2 and map extended community. So that's the update we made. So please, next slide. So this is the notice to other draft authors. So the draft MHKK, DMM, SRv6 MEP architecture, it's the superseded draft is no more updated. So please refer the this draft MHKK, DMM map architecture as your reference. I still observed some draft before the previous document. So please update the latest draft in your
So those
draft.
are non-normative references or normative references?
Either both.
Both. Okay, thank you.
Okay, so next slide, please. So I have some question many times, so I noted that question and answers. So what question is, isn't RC 9433 SRv6 map itself? So answer is 9433 defines the service mobile user plane behavior under the 3GPP 5G architecture, which is not adopted by 3GPP. And next question is, what does 9433 contribute map architecture? The answer is, as map architecture designed as a pluggable user plane for any mobile service system. So 9433 provides a data plane option in SRv6 case under the map architecture. Okay, so that's totally different. Okay, next slide, please. So our next step is I will request the working group adoption. So that's all I have today. Thank you. Any question, clarification?
Sort of sound. Any questions, comments on the presentation? Ketan?
Hi, Ketan Talavlikar, Cisco. I would support the adoption. I just want to also remind that there is a draft in BEST working group, which has the BGP extensions that was indicated here. And I think adoption here would make it possible to move that draft, which has been in BEST for a long time, for adoption in BEST as well. Thank you.
Say that again. So you're suggesting
There is a document,
Yeah.
BGP document in BEST working group in the routing area that depends on this adoption of this document to move on.
Okay, thank you.
Thank
Any
you.
other questions, comments? Eric?
It looks like you're targeting standards track.
Sub standard track, yes.
Given what happened with
At
9433,
yeah.
what do we want to do?
Yeah, maybe something happen. I'm happy to proceed the work with the information or standard. Both case it's acceptable. I think
Informational is okay. Or,
if it is preferable, it's okay.
I mean, it'll be someone from 3GPP who raises an objection, not me. So,
Yeah.
but we'll need to ask.
But so far, I haven't received any objection for standard track yet. So let's see.
Well, it hasn't been adopted yet, so yeah. But as soon as it is, that
Exactly,
will undoubtedly
exactly.
raise its profile.
Let's see. Let's see.
Till,
Thank
till the last. uh, TNG on the mic, please. Yeah.
Regarding that, the RFC, the first,
9433. Yes,
yeah, at 9433 here, the things like the first bullet claim, okay, there's some very good things, but not adopted by the 5G architecture here. And then your proposal is like more generalized for any mobile system. And then the 9433 is only under SRv6. Yeah, from the projection of the 3GPP, I think the 5G or 6G. 6G is not going to revolution. It's more evolution. So it seems it's going to not going to be dramatic change. So
but one correction, TNG. I think before on 6G we do not know yet.
yeah, no,
right?
no,
So
no,
we
the-
cannot
the-
say
yeah,
that
yeah,
it's
yeah.
going to be evolution, revolution, or we do
Yeah,
not know
but the
yet.
thing
Yeah.
here is like so original one is not adopted, and then what is the projection for this one to be? That is actually my concern. Yeah.
Okay, Eric.
Can I clarify what I thought I heard? You're saying that this is more general than just 3GPP, right? Uh, right. For any mobile system. So, oh, I see. Right. So, with that in mind, you're thinking the standard track could be possible, um, since it doesn't necessarily target 3GPP. specifically.
Yeah, it's not tied to any specific architecture. Yeah, absolutely. Yeah.
Interesting. Okay.
I think any other technical feedback. I think before we move towards adoption, right? How many people have reviewed this document? 1, 2, 3, 4. Not okay. 3.5. So, so I think we need more reviews. Can someone sign up for the reviews, please? Any volunteers? Okay, you already reviewed. Okay. Okay. So any other? Okay, thank you. So if you can post some comments, I think once Satoru-san, once there's explicit feedback from, then we can move to the next step. Yeah, thank you.
Lionel Moran again.
I know.
It's along the question regarding the status of the next to be RFC. I didn't see. So I remember that we have the discussion regarding 9433, and especially because in this initially in the draft, some part of the document where so it was requested to have an RFC to be able to for some IN assignments. But here in this draft, it seems to be only for information. This is what you can do. So I think that whatever the output of the discussion in the working group, do you think that informational would not be good enough because actually it is the main content of the I think it doesn't preclude to after that to use this draft this RFC as a reference for others, but from the content point of view, I think there is nothing to be standardized, let's say. It's only how it could be done, and it is perfectly defined, so we will review it. But just to be clear on that, there is nothing to be standardized based on this draft.
Basically, this is the base architecture document to invite the proposal or protocol specification be as the standard track protocol. Okay, so in that sense, I think it be standard track. That's the my opinion, but it includes the other side of the network, other side of the standardization work included. So then the first try could be a informational track. That would be good. After that, we can propose that architecture again with standard track. That with much more cleaner in the sense of the ITF. That would be the path.
If I may, because I remember that in the past we had several times this discussion, and for everything regarding problem statement, for instance, or baseline for solution and so on, just to speed up the work on that, it was easier to go for informational, even if after that we have further work to provide standard track RFC, for instance, for specific solutions. But it was you answered to my comments. Thank you.
Thanks, Lana. Ketan.
Hi, Ketan Talaulikar, Cisco. Just to add on to that, as I mentioned, there is a BGP draft,
Right.
which is standards track, that kind of normatively references
Yes,
this
sir.
because it depends a lot. Now, this is within the IETF, so I mean, it's something to check with the best working group chairs if it is okay to have this informational and the BGP being a standards track.
Or the other option is the other, that one will go informative as well.
It's possible, but I
Possible,
would
yeah.
say not
Yeah,
ideal.
just, yeah.
But it's in if it is the case where the best working group doesn't refer the informational architecture document to propose to bring the standard track protocol, we c- we s- we get the RFC number for this architecture draft as an information as soon as possible, and then propose again the standard track draft based for standard track protocol work. That could be a you know
So thanks, thank you,
possible
Sadar.
work, possible path.
Thank you, Ketan. Yeah, I think a few. I think next steps, right? I think let's make sure we get some technical feedback, and then whether to go informative or normative, we can have a discussion. And after this, let's defer this to next step. Once the technical reviews are complete, then we can decide on that, yeah, at the time of adoption.
Okay.
Thank you so much, Sadar-san, for
Thank
the
you.
presentation. Yeah. Next one is which one? Mock architecture, traffic steering. No, traffic steering. Mobile traffic steering. What Ravish? What?
No.
Okay. See. So, traffic steering, complete cats, 6G reset. Oh, map architecture. This is what I see. Okay, let's see. Traffic computing aware traffic steering. Oh, how am I missing some document? Okay. Yeah, that's what I see.
Really?
Yeah, are we missing some document?
Missing some.
But we didn't upload. It's already in the.
This one?
Yeah, but no, we not uploaded anything, right? Yeah.
Okay,
So
let's.
maybe let's get started with in the meanwhile.
Yeah.
Next is mobile traffic steering. Marco. Marco is, yeah, you can present. Yeah. Yeah, I'll write for you.
Okay, so this is mobile traffic steering. Again, briefly about the background, we had a first draft before last IETF. We updated to version 1 before this IETF. Next one. Quick context and background. So at IETF 116, we revisited some advanced mobile scenarios as discussed by the early times of DMM. There was room for documentation and standardization. There was growing interest, and people asked for documentation. We had a public site meeting in San Francisco, and from them, continued discussing use cases and the technical requirements. And now, for this draft, we have documentation of the use cases, scenarios, architecture options, where we look at two options here. And we started to draft an information model. Next one. So the basic scenarios comprise decoupling of a mobile node's IP address from a topologically matching user plane anchor, which gives flexibility in steering traffic to one or multiple user plane anchors that are associated with a single or multiple mobile nodes. Also, we look at network function ephemerality or mobility. So ephemeral nodes may be due to nodes implementing an energy saving schedule, or they are mobile on their own, like if they are placed on a non-terrestrial node like a satellite, which is scenarios intensively looked at today. In this work, instead of interfering with existing mobile communication system architecture, we want to rather complement them from the system up to a data plane, a data network and the network in between. So instead of interfering, we rather look at touch points, which is in this example between mobile control plane and the transport control plane. Next slide, please. So the past discussion, we started to raise some advanced use cases, describe them, discuss them, check if there is interest in this work, and obviously there was. We checked also about value and relevance of that work. So if there is a critical mass of contributors to drive that work ahead, I think that can be improved a little bit if there is common understanding and interest in this work. Technical scope, referring to this sketch here, we looked at different functions and reference points and wanted to see where does it make sense to do work without reinventing what exists already. So on the data plane, the reference point for, there is a lot already. And today also we heard about segment routing kind of solutions here. So this is something we just want to reuse, whatever makes sense. The main new aspects which we see is the touch point between the two control planes of the existing mobility communication system and the transport control plane. And this is where we started to draft some information models. Next one. Okay, some of the use cases that we discussed for operation in an evolved system is, for example, user plane anchor relocation during mid-session of a communication between a user equipment and any service. So for various reasons, user plane anchor may be relocated for route optimization due to mobility, not only mobility of the mobile device, but maybe mobility of the serving data network. So here, UPA relocation can be either proactive, driven by a mobile communication system, but maybe also reactive in some advanced scenarios. So that's what we discuss here. We may look at multiple user plane anchors that serve a single mobile node concurrently and to steer traffic. These scenarios have also been addressed a long time ago in DMM with a mobility floating anchor. So these seems to be interesting and valuable scenarios, not necessarily being supported by all mobile communication systems per today, but evolution is what's always being considered and discussed. And let's start to have a discussion here. Node ephemerality, as I said, we may apply to a user plane anchor, but also to data plane nodes and data network nodes, or the associated P routers. Route optimization and control between UPAs. So if we have user device to user device communication, we may want to have control on how traffic between user plane anchors travels. And also end-to-end QoS has been addressed here. We don't look particularly on QoS here because that's a longer story, but we could look at this if we are confident in that we have all other information elements and information models tackled here.
So,
Next
so
one.
Mark, if I may ask a question
Sure.
on node ephemerality, what exactly is the requirement there?
The requirement is that we may have nodes on the path between a mobile device and its service that may disappear for various reasons. So you need to steer the traffic if you want to keep an optimal path, for example. So an extreme scenario plays a user plane anchor and a data plane node as a virtual routing function on top of a satellite. The satellite may move. So it may replace it by a different satellites covering the UPA and DPA function.
Good, thanks.
Sure. Next slide, please. All right. We presented this a couple of times. So this is one of the two options in terms of architecture aspects that we consider. So we may have a mobile communication system, which we don't touch. So from the data plane, from the user plane anchor up to the data network, that's what we want to complement here. And having data plane nodes, which are routers. Here only the kind of corner case routers close to the UPA and close to the data network are shown. And these are under control of a dedicated control plane, which has an API running with the mobility control plane. So this is one of the interfaces and APIs that we want to look at. And this is how we sketch that kind of architecture in the current draft. Next slide. The other case we look at is without having a dedicated controller, but rather rely on a distributed control plane, where we have data plane nodes or virtual routing functions associated with the user plane anchor. And then updated routing information are propagated towards the data network by means of BGP or any other kind of routing protocol. Here we don't want to be specific. What is needed in any case is, again, an API between the UPA and the data plane node to retrieve the required information that's to be propagated towards the routing network. And that's how we covered that case in the draft. Next slide, please. So we started to draft a bit of information models, and that's only one example. We did that for the UPA, we did that for the data plane nodes. And these are the two cases that you see here. A reference point between the mobile communication system control plane and a dedicated mobile traffic system controller, mobile traffic steering controller. And in the other case, with a decentralized routing plane, it's an interface that we also need between the user plane anchor and the virtual routing function to retrieve the required information. So information models beyond the typical user IP address or IP address prefix or traffic classifiers, classified traffic associated with a particular mobile node. We drafted information elements for these three types of nodes: user plane anchor, data plane node, and data network. For example, exposing the control plane URI. So a data plane node needs to know how to talk control plane with the UPA. If we have a dedicated controller, so the mobile traffic steering controller in the upper picture needs to know how to connect to the mobile communication system control plane. So this information to be exposed, then forwarding IDs like IP address, MAC address, but also lower layer kind of labels should be exposed. Then topology information is in particular required for optimizing the route, in particular if we have ephemeral nodes, which is a peer or move. So that could be optimized over a session time. Adjacency type is, for example, if a data plane node is adjacent to a user plane anchor or adjacent to a data network. If we have the routing distributed routing plane as a deployment option here, so a data plane node may be either close to a user plane anchor or collocated. If they're collocated, they always go together, right? So that's information that can be exposed, which are valuable in terms of reorganizing the whole network and steering the traffic accordingly. Again, this is just drafted. This is to be discussed, and so also other groups in the IETF do valuable work which can or should be considered here. And we do that by just referring to an URI which provides supplementary services. So the TVR group, for example, exposes and specifies data models that give a hint about how long a node will still be available, right? So I think this group considers this information elements more, or attributes more, to be exposed with routing protocols. Here we just consider a third party kind of API where this information could be retrieved. If we can embed this also to the information here and directly communicate between control plane nodes, that's another option. So we are a little bit open here, but this is just a starting point regarding the information models. And let's see what the community thinks and if we get more feedback here to tailor this a little bit. Next slide. So this is the structure of the current draft, which starts with a general introduction and reference architecture in the view of the full end-to-end operations. And then we discuss several use cases. Then the two deployment options with a dedicated control plane and a decentralized control plane. Design recommendation is still to be done. So here we focus in this version of the update on information models. And then we ask for your feedback. And in particular, if you move to the next slide, please. Check if there are comments about the use cases, about the scope of this document, if you still consider it valuable and if you want to support it. And in general, to ask if there is interest in the group to proceed with such work or not.
Thank you,
Thank you.
Marco. Carlos.
Carlos Bernardo, UC3. I haven't read the draft, but I find the whole thing very interesting. So I will read and I will provide comments. I have just a question. How does this relate to the CATS effort, the computing aware traffic steering part? Because, well, my presentation after this, I think, well, today in the agenda is about something that I think is related to this, but also to CATS, try to do an architecture supporting this computing aware traffic steering and then doing the mobility. So I don't know if you have considered also use cases related to CATS in your document.
No, we want to keep that orthogonal to CATS and not interfere with that work. So CATS is about computer-aware traffic steering. So we don't have any mobile aspects here, right? So we have mobile nodes which make use of a service in a compute data network, and we steer traffic accordingly between a user plane anchor and that network. I think CATS is also, it's mainly about uplink steering, no?
Well, as I understand it, is for both things. So,
Uplink
well,
and downlink.
maybe
Okay.
we can discuss also
Yeah.
when I present my
See,
slides.
it's more a static scenario in my view, but we can discuss. Of course, we should not overlap and do the same things in different drafts. Yeah.
Right. Thank you, Carlos. I think one question, Marco, on the multi-UPF sharing mode. How does the N6 steering work? Is it based on policy? You switch some packets to one UPF to another packet to other UPF. What is the policy of switching from N6?
Policy can be any. Enforcement of steering is on per host route, per host or per flow or per group of flows. So you're
It's still a single host, still same IP, right?
single host, but
Yeah.
you may have different paths for different flows between a host and a service.
So you need some N6 state.
You need states at least at the kind of corner case routers to have host routes being enforced.
Okay, John.
Yeah, John, a quick question for clarification. I was a bit confused whether the steering is per flow, maybe related to the previous question.
Yep.
Is per flow or per the set
Session.
of flows that correspond to that route? Because you're talking about transport and the mobility management in 3GPP is per session or so how does that map? There was
We're not specific to that. I mean, even though current mobile communication systems may have traffic classifiers to split traffic going through different paths or access networks, right? But it's the same UPF in case of 3GPP that does this classification. Here, we may do this classification already at a data plane node in the network. So if this is on a per session or on a per group of flows or on a per flow, we don't want to be specific here. It depends on the type of classifiers that we put into the information model. So being flexible here, but I mean, it needs to be clear since we talk about host routes and not necessarily a routable IP address of the UE, we need to have more states and the more fine granular to implement these policies.
okay. I think that was the question in terms of scale, since we're
Yes.
talking about a transport, what the view was. All right, thank you.
Thank you, John. One last question, Marco. So I know 3GPP doesn't recognize the N6 router, but do we need since we need state per flow state or application state, right? Do we need policy interface to N6 router?
what is an N6 router?
And N6 on N6 interface, right? You need some this steering,
If we
correct?
refer to 3GPP 5G architecture's N6 reference point as an example, that's a interface that we focus on, right? So we apply data plane nodes, which are routers that are either collocated or loosely coupled with a user plane function into GPP.
Okay.
So that's where we enforce the routes to have full control on end-to-end traffic steering.
Thank you, Marco. Any questions, comments? I think this was presented and looks, I think, so far. Oh, you locked the queue. Okay. So, sorry. I can't see the process.
No,
Oh, next one. Okay. 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 So next steps, I think, if there's any feedback, if you can post it on the mailing list,
Yes.
we'll go for the. If there are no comments, we'll go for the adoption call. Yeah. Yeah. Would that work, Marco?
Thank you.
Thank you. Okay. Next. What's the next one? Okay, the slides.
I think he
No
passed
slides?
the control to inside.
Okay, what's his name?
Complete stop the sharing.
I'm not sharing. Cats. Next is computer traffic steering. I think we have a remote presenter. Min.
Just can you hear me?
Yeah.
Thank you. So I'm Mingok and I present the document Computing Aware Traffic Steering Consideration for Mobile Isoplane Architecture. The next slide.
You're controlling.
Okay. I cannot control it.
Can you switch? You're sharing. Who is sharing? Is it here? Okay, let me share actually. 1 second. Yeah. No? Oh, okay. Which are the slides? I don't see the slides. Give us a second. We're trying to figure this out. Just more.
I can control it now. Okay, so the target problem of this document is based on the previous document presented in this meeting. It's the DMM map architecture. And this document aims to enhance this map architecture with a computing aware traffic steering concept from the CAS working group to address the optimal routing path selection problem in multiple service instant network scenario. So this is the update that we have made compared with the previous one in the previous meeting. And in the previous one, we only provide a centralized CAS move, and in the comment, we also receive comment about
We lost you.
Tinok, we couldn't hear your voice. Do you speak something?
I'm currently losing my. Okay, you can't hear. We go to the next presentation. Okay, we'll move to the next presentation while you figure this out. Next one is what? Carlos. Complete business one. Cats.
Okay, thank you. I'm gonna present. I will be brief. I will not consume the 15 minutes. Some drafts that we originally presented in CATS, but is that they are related a bit to DMM because, as you will see, propose some extensions to proximal IPv6 protocols to support mobility in a CATS architecture. That's why I mentioned to Marco that it may be related to their draft. Next slide, please. So there are a couple of drafts and one more that is coming. One is kind of presenting the baseline architecture, which is simple, is basically how to, it's an architecture leveraging the mobile IPv6 protocols that we have to support the CATS architecture. Keeping in mind or thinking of supporting mobility in that CATS architecture. It's true that, as Marco mentioned, that in CATS, as far as I know, they are considering right now a kind of a static scenario with no mobility involved. For those that are not familiar, the CATS is the computing aware traffic steering. So the idea is that when there is a service to be deployed, not only the latency of the networking part is considered, it's also considered the latency related to the computing. So the architecture should support selecting a site, and that's why in this picture we have different service sites where different instances of a given service may be instantiated. That together with the networking latency or delay between the site and where the consumer of that service, the UE, the terminal in this case, is considered both the networking and the computing delays, so they are less than what the service requires. So with that in mind, and there are some architectural components, the egress cache router ECR and the ingress cache router ICR. The cache architecture, the cache working group is looking into solutions for this. And here we basically propose an architecture that assumes that there is a kind of an anchor for the IP address used for the service on the ECR, and then there is a tunnel to the ICR, the ingress cache router. So basically, in this tunnel is moved if there is a need for the service to be moved as a result of changes on the networking conditions, changes on the service sites because of the computing delays associated to the computing capabilities of the service site, or mobility of the terminal itself. So all these type of triggers may need or may trigger the necessity of moving a service or moving the terminal and updating the networking traffic steering. And what we have in mind, or what we propose in these two documents and one more that is gonna be uploaded soon, is to leverage on proximal IPv6 mechanisms to support this. Next slide, please. So I will not go into the actual details. This is just more a teaser for you guys to see whether you think this is interesting. But the idea is that, next slide. All these messages that you see here, and we will not go into the details, are basically for different options that we consider in the draft. One option is based on a CATS controller, so kind of similar to what Marco mentioned. There are some other options based on the actual routers, the ingress router and the egress router communicating among themselves in a more distributed way to support first how to select a site for a given service, meeting the requirements in terms of latency, and then once we have that, how to support mobility if the terminal moves or if the conditions change and we need to move the service from a service site to a different service site, how to update everything leveraging the mobile IP, in this case, proximal IPv6 mechanism. So we define some new messages in the draft, but this is just an example. We call them CATS query and response and CATS request and CATS acknowledgement for the part about knowing what are the potential candidates to move a service, and then for the actual request to move a service. And these messages, next slide, please.
So one question, Carlos. You can't use a standard protocol without any changes. Appears to be a standard application of the mobility protocol, right?
I mean, that's why I say that the name of the messages are like examples, because as you will see later, those are updates of existing mobility messages with new options to support what we need for the CATS specific use case.
So you need new elements to be carried.
Yes.
Okay. John, I think John is in the queue, or you can take now or later. Yeah. Okay.
So you go to next slide. So these are the new options. Basically, the query, response, request, and acknowledgements are like PBU, PBA messages.
Yeah.
Okay. With some specific minor things. So it's true. And that's why I'm presenting here, because it's a mobility-based architecture or protocol. And then there are some new options, mobility options, to support what we want to do. For example, to support the selection of which is the proper service site to instantiate a service or to move a service with the requirements and the conditions, these type of things. But yes, it's true that is very much applying mobile IPv6, proxy mobile IPv6 to this specific problem. And the last slide, just to do some context and some potential next steps. This was presented in the CATS working group at the IETF 119. The CATS working group is not now working on mobility per se, but I think it's something that they may consider in the near future, because once they have overall architecture supporting mobility, there are some use cases that benefit from supporting mobility. And at this point, what I'm looking for is just feedback from both the CATS and the DMM working group. So I'm not asking for any, of course, adoption or anything like that, but just interest from you guys whether this is you think this is an interesting approach. And as we mentioned, is basic usage of proximal IPv6 protocols for this purpose.
So one question. Thank you, Carlos. One question: is the mobility use case captured in the CATS requirements documents?
Not yet, but it's something that we will. I think the CATS as it is right now, but it's something I want to discuss this week. They are not looking into the mobility part yet, but I think it's a natural future step once they have the baseline architecture.
Thank you, John, and then Marco.
It's a question for clarification. So if the service is stateful, for example, if it's a video that's playing and then the user moves, does the CATS routing use service state? For example, if you're in the middle and you move, will it take it to the correct service instance?
Yeah, there are two things. If the user is moving, the terminal is moving, there may be the need for moving the service instance, or there may be not. That depends on the scenario. Okay, if only the traffic stream needs to be updated, but the service instance servicing the service or providing the service is the same, you don't need to do this. Right. If you need to move the service, yeah, there's need to be some service migration and a state. So if the service is stateful, you will need to transfer the state. Yes.
I guess this sort of came up in some of the work in 3GPP, and we found that at least people are deploying the CDNs found that if you have a stateful service like video, you're going to run into problems when you're using routing that does not have that service instance. And I was wondering if this can support that or not. That was more or less the question.
What do you mean by supporting that?
So, for example, if you're in, if it's video server 1 that's you're playing out of, I mean, it's the same address map perhaps, but now you go to a new location, and it will pick up another instance of it, which doesn't have the previous state. So that was the problem.
Yeah, the idea here is that the state will be transferred, and we keep the addressing and the tunnel. We basically make the traffic move to the new location where the state has to be migrated.
I guess John's question is not the routing state, but the actual video service state, application state. Application state we are moving from.
The application state has to be transferred to the new service site, yes.
And how would that be done? Is it a CATS extension of some sort that keeps
not
per flow, or
no, that's something that is out of the scope at this point. I mean, not really specified by
okay, so
cats or
then
by this. Yes.
Let's take this. I think this is a detailed one,
yeah,
John. That's okay.
I can talk to you offline.
Yeah,
Yeah,
sure.
Marco.
Thank you, Carlos. So as far as I understand, the main use case is, for example, in terms of dynamics, to serve a mobile user from a service network, as you call it,
Mhm.
and then during runtime to change the service network and keep service continuity, right?
Yes.
Okay. If you go back to slide 2, please.
Slide 2.
So you look at a mobile network, but I see the whole magic is coming from an overlay with a lot of
Yes.
CATS agents, right?
Yes.
And you place CATS agent on a radio base station, as we see here, and on
On a-
something above. So the thing above the other tunnel endpoint, is that a kind of anchor node, like
Yeah.
Proxy Mobile IPv6 home agent?
Yeah. So the idea is that we have an ingress, a router in the ingress, where depends on the specific deployment. We have an anchor close to where the site, potential sites where you can instantiate the service. So it's like, yeah, like an LMA or like a home agent kind of thing. And you have the tunnel in between that you update as a result of the mobility of the terminal or the mobility of the service because of changes in the network or at the service side. Because if the computing delay, for example, you have instantiated the service at that one, is here n minus one, and the delay of the computing increases and the overall delay is above the threshold that you need of the requirements, you may want, even if the terminal has not moved, you may want to move the service to this new service instance. Okay. And basically, yes, you keep the same IP prefix being used for the service. You move the tunnel with an overlay. And then, yes, you need to do, if the service is stateful, you need to do the transfer of the state. Yes. That's how that is done. We don't address that in the draft. And that's what we do. And at the same time, there may be triggers of these updates because of the mobility of the terminal. Terminal may move to this new ICR, and you need to do this.
So mobile components are, as usual, the mobile node, but also the serving network.
Yeah.
So if we don't call it CATS, but mobile edge computing, it's the same kind of scenario to look
Yeah,
at, right? Which
but
is a
Exactly.
follow-me kind of
Exactly.
edge. Okay, thank you.
Thank you, Marco. I think interesting. Any other comments? Tianji, quick. We only have 30 seconds.
One clarification part. So since you are running the CATS agent on the terminal itself, like your user equipment, are you going to?
that's an option. I mean, in the draft, I didn't go through the details. There is an option with the CATS aware terminal, but there is options with the CATS unaware, so with no agent on the terminal. So both options are feasible.
Okay, I can give you one case that's being standardized already here. It's like edge computing. And then there's one thing for the UPF, basically the egress part, that can help to select the edge servers
Mhm.
based on so far is the delay. Well, from the UPF to different EAS and to find which one will be best, and also get a closed loop control in that case. So, and also with the mobile network, with the help from a mobile network, you can go into you can get the stateful service. So that you can check, or I can check with you offline about that thing.
Okay, but
Yeah.
here we also considering the delay not only of the network but also of the actual
Yeah,
edge.
exactly. But the things that I mentioned is the standardized part in 5G is only on the delay part, but the
Okay.
computing not
Okay.
yet. But
Okay.
that one maybe for the later consideration. The delay has been standardized. Yeah.
Okay.
Okay, good point. Thank you, Tianji. Thank you, Carlos. I think we'll, yeah. Okay, next is introduction to 6G research. Yeah, yeah. One present. Will, sorry, which one?
So SRH reduction.
Sorry, before that, I can't see the slides. How come? Come on. Here, if you click on the share slides. No. Yeah, share slides. Yeah. Okay. This is SR. How much time we have? Okay, we have two more presentations, one for SRH reduction for SRV6. Yeah. What's this? Yes, on.
Uh, Hello everyone, I'm Yuya Kawakami from SoftBank. So today I have I'd like to make update about the SRV6 MUPs, SRV6 and MGTP6C behavior. Next slide, please.
You're controlling.
So first, let's recap this draft. So we have SRV6 map RFC 9433. This is a defining and MGTP6C behavior to interact with IPv6 genome B. That means translating SRV6 packet into the GTP IPv6 packet. But this behavior requires two seeds to restore the information which is required in the GTP headers. So, but the processing the two seeds at the same time is a little bit difficult and hard work for the hardware. So I propose that this behavior NMGTP6C reduced, which is compressing these two seeds into the single seed by utilizing the ISD routes, interwork segment routes, that is defined in the SRV6 map architecture draft. And then, by utilizing this behavior, so we can achieve the SRV6 map, even though the also both of the IPv4 G node B and IPv6 G node B. Next slide, please. So I proposed this draft last November's IETF 118 in Praha, and no big update and objections from attendees, and just we made just fixing the typos, and but at that time, so we have a feedback about the order of the field in the seed, and this feedback is still under discussions, and some implementations is under development. So we are now going to test the implementation of the based on the feedback and evaluate that. Next slide, please. So for the next step, so the document, we like to ask working group adoption. And for implementation, so we continue to implement software and evaluate the performance.
Thank you, Yasan. Okay. Does this update on 9433 or is it an
That is an extension.
extension? Okay. Thank you. Any questions, Ketan?
Ketan Talaulikar, Cisco. Just a question. I'm not sure the SRV6 endpoint behavior has been allocated for this or not yet.
Not yet. Okay.
I would suggest that you allocate it already because it's anyways first come first serve.
Yeah.
You can get it for the draft.
Yes.
It will help in our implementations.
Thank you.
Okay, so this appears to be a well-defined, more incremental thing. Fundamentally, we are not opening any new issues. Any questions, comments on that?
You intended this draft to be informational or standard track?
I believe so. This draft should follow the status of the RFC 9433. So that is informational at this moment.
Exactly. It's so much tied to 9433. If it moves forward, it has to be an informational track. It cannot be on standards track. Yeah. Okay. Any questions? I think given that it's a well cut out work and small incremental work, hopefully if there are no objections, we should be able to move forward. But yes, with that, yeah.
One clarification. Can you go to there's a page. Yeah, before yeah, here. The things like try to get clarified. Here you're running your GP tunnel between the GNOB and the map. And then where are you going to terminate your SRV6 part?
SRV6 terminated the MVP PE1, the center part of
The MUP part.
between
Okay.
the two clouds.
Okay.
Oh,
So
careful, careful.
the mapping. So the mapping is from the GDP to SR basic will be the PE. Okay.
The PE1, yes.
Okay. Yeah, but how are you going to get the GDP tunnel ID, the TID, all kind of information to be distributed from the mobile domain to the MUP domain?
That is based on the RFC 9463.
Okay.
Yeah. Same as that.
I think to answer the question about how to get the TID from
Yeah,
control
yeah,
plane,
yeah,
that's
those-
the part of the map architecture, SD1 route,
Okay.
BDP.
Okay, if there are no, thank you, Yasan. We'll take it in a mailing list. If there are no objections, we'll follow up with our AD and we'll go to the next steps. But appears to be small enough, maybe, hopefully. Thank you. Next final presentation, or maybe on, okay, this is David Lake on 6G architecture. I think before we start the work, a few rules. I think we are not, it should be more informative, step one. Point number two, this should be, the discussion should be about how DMM can contribute to 6G. Point number three, we are not going to take a position on the, or if there, two contending proposals in 3GPP, we are not going to say this is better or that is better. We are not going to enter into that discussion. It's purely, or the objective is how IETF DMM working group can help 6G efforts. That's all. I think with that, Mr. David Lake.
Thank you. Can you share the slide? Thank you. I'd like to introduce the 6G Reset Initiative and just explain the reason for this and who's backing it and what you can do to get involved. Next slide, please.
Sorry.
Thank you. In terms of 5G, there's a general feeling amongst the proponents of the 6G Reset group that there have been a lot of big promises, but in terms of results, some of those have failed to meet the requirements of end users and consumers. Also, it's taken a very vendor-centric view of the world, and the 6G Reset group wants to take a differing view. And I don't think any of us can deny that there's been some unimpressive economics across the whole piece. And again, this is about taking quite an economic, financial, and business view of where we are with mobile connectivity. Next slide, please. The goal of the 6G Reset Group is to deliver a new standard of connectivity that's rooted in the needs of stakeholders, whoever those stakeholders are, and part of that work is to identify who those stakeholders are. It's also to try and build some growth industries rather than some of the things that we're currently seeing, and to encourage new entrants and to encourage alternate ways of thinking about what 6G could be. Next slide, please. There are three main goals to the discussions that we're having at the moment. The first one is about ubiquitous connectivity, irrespective of location, irrespective of technology or the standard involved. What is the correct way of providing connectivity for specific users, use cases, new devices, different ways of thinking around this? So we're looking at the whole range of connectivity, not just 3GPP, standardized connectivity, but also looking at some of the Wi-Fi, also looking at the IoT world and trying to take a holistic view of RF connections. Again, not even looking at protocols. So trying to ignore any existing protocols or new directions, existing directions, and look across that. We're not looking to follow one standard or one technology. Next one, please. In terms of economic viability, we're looking to reduce the cost. How can this cost be reduced, both for the 6G operator and who are those 6G operators? Are they existing public networks? Are they existing private operators, enterprise users, community-based? Basically trying to work out how to make sure that they become more profitable and providing a service to consumers, a cheaper service to consumers, or a better service to consumers, or one that's linked into the finances and the economic success of both the operators and any stakeholders to that business. Next, please. The final goal is to think about sustainability. Do we have the most efficient network builds? Do we have the most efficient use of RF resources? Do we have good usage of protocols in terms of the amount of energy that we use to transmit those protocols? How can we reduce the amount of change that we need? How can we innovate? What is the correct way of providing the scope, the scale of connectivity that we need so that we serve an entire citizenship rather than individual user groups? Next, please. So we believe that within 6G, we need to work differently. First off, we need to talk more to government about what it is and isn't achievable. Secondly, we need to have a better link between the consumer outcomes required and the businesses that are providing that. That's both vendors and the operators. And then thirdly, there needs to be a society understanding of what it is that wireless connectivity needs to provide across the piece. Next slide, please. How are we doing this? There's 3 initial supporters to this group. I think they're all pretty well-known names in the industry. And there is a LinkedIn group, 6G Reset, which currently has over 300 members on it and has quite a lively discussion that ranges from who are the stakeholders to what are the technology. And it's represented by a whole range of individual and personal opinions. Final slide, please. What am I asking? Please become active in the group. Please become active under Chatham House rules. There are no corporate opinions. It's supposed to be individuals that have a view. Join the conversation. Try and position ourselves for what 6G may be, whether it's evolution, revolution, whether it's some a different way of connecting all these pieces together. Please join in and join the discussion and help us define a different path for 6G. Thank you.
Thank you, David. One question: how can IETF DMM working group help you? What do you need from us?
Really, just individually join, come in, make some decisions about how to enter into these conversations. Talk about where 6G could be going as far as DMM is concerned, and then really tell other people to get involved and start having an opinion.
Okay, thank you. Any quick
Thank you.
follow-ups? Yeah, Marco.
Thank you, David. Let's ask vice versa. I mean, since you present this in DMM and you probably listened the whole session, so any of the work presented and discussed today, do you think it's to be further considered and valuable for 6G? Because you know about the requirements where you would like 6G to go. So is there anything you see valuable that has been discussed today for your 6G directions?
I'm going to speak completely personally that I see 6G as being not just the current 3GPP routed solutions. For example, if I'm connecting over a private Wi-Fi or, for example, as yesterday, a train Wi-Fi system, it's currently quite complex to consume those applications when I have a subscription to a 6G service or a mobile service provider, and then it's very difficult to have that same level of control over my application. One aspect that I think could be useful is to think about how current 6G within the MNO and the 3GPP environment could be federated into authentication within other wireless domains. An example could be WBO open roaming, but another example in the IoT space could be into the LoRaWAN environment or into a satellite environment as well. So it's really about thinking, rather than thinking about what changes within individual domains of 6G as is being designed, say, through DMM, it's how does that integrate into the other adjacent parts of wireless connectivity.
Good. Thank you.
Okay, thank you, David. Okay, with that, we'll move to
Thank
the
you.
next. Oh, yeah, final topic. Just I think, Min, or is there any? Yeah, I think. Are you there to present? Etienne, yeah. Yeah, if you can share and complete your deck, that will be the final presentation. You can-
Okay.
Yeah, Etienne, yeah. You know.
So yeah, this is what I previously started here. So in this update, I revised the necessary information that need to be included in the routes of the both deployment option, and then I provide the procedure of how the deployment option they can support the new EV request and EV mobility. So the first thing is a centralized cut-off. So for this one to be happen, we need 3 routes. But first of all, I need to clarify the notation here. So the CIS ID here is an ID that identify. Normally we have multiple service. So this one identify which is a service. Then one service might have multiple service instance, and the CIS ID is the one that identify which service instance is. And the CPS is a cache path selector, the one to select the optimal instance out of the instance. So for the centralized customer, we have the centralized path selector is located at the centralized MAPC. And then we need 3 kind of route to enable this deployment option. First one is a direct segment discovery route. And the session transform route is the 2 route inherited from the original map graph. And we only need the cast metric update route is an additional route. So the information that we revise compared with the previous document in the previous meeting is that we think that all of these routes need to include the CSID and the CISID inside the NLRI information. And for specifically the direct segment discovery route, you need to include the corresponding PE attached to the service instance because it advertises the direct segment reachability information. For the case metric update route, you need to include the case metric because it's advertise the case metric from the P of each instance to the centralized controller. And for the session transform route, it selects the optimal instance so that it need to have the session TID relate corresponding to the UV request and the optimal CSID selected from the cat path selector. So this is a procedure that we think that it can enable this architecture to work. So first of all, before an EVE request arrive, any service instance that joins the network to the PE, its information need to be advertised via the direct segment discovery route. So we see it includes the service ID of itself, then the service instance ID of it, and then the P basic ID for example. Then when an UV request arises, and the session information is gonna be provided to the MAPC. And the MAPC will know which service ID is requested. And at the same time, it's based on the cast metric to select the optimal service instance ID. For example, here is the B. Then it will attack the corresponding TID from the session information to the session transform route and push it into the PE that attached to the RAN. And in case optimal service instance is changed, then the CPS need to select another optimal instance, and a new session transform route is provided to that P at the RAN. In case of EV mobility, then the same thing happened. And in case when you move to a new RAN, then the session information is provided to the MOSI, and the MOSI need to select optimal for this one and send the session transform route to the new RAN that the UEA attached to. For the decentralized, for distributed capacity option, in this one, the CAS facilitator is not located in the MAPC. Now it's located as the PE, HPE that connected to the RAN. For this one, it only need the two original route from the map draft. And the other information, the CAS magic now needs to be provided inside the direct segment route. And for the session transform route, it doesn't need the optimal service instant ID here because now the CPS at the PE gonna select that by itself. So for the new EU request, after the direct segment discovery, it periodically advertises to the PE at the runtime. The PE at the runtime, it can select the optimal instance by itself based on the metric, and then it can set up the corresponding route to the selected instance. In case of chain,
you may want to wrap it up. Yeah. Please.
Yeah. For the UE mobility, it's the same. The P as a run, we select it, and that's it. I think we share any comment about the graph.
Thank you. Any quick follow-up?
Yes, this is John. I have the same comment as on the previous CATS question. The CATS is used for determining the correct route and selecting a service. But the service instance, if it's a stateful service, then there's a problem of how do you convey that you reselect the same instance after mobility. I think that's missing here. Any cast will select the best one based on the CATS or any other criteria, but it will not remember the correct instance to select.
Yeah, the application state. Yeah.
So that I'll post it on the list so that it's understood. Thank you.
Thank you, John. Ketan, quick follow-up.
Ketan Talalikar, Cisco. This is about the CATS metric affecting the PGP route selection. As I understand, this is something that should be discussed in a working group which has BGP expertise as well. There have been concerns about these metrics and the churn and the instability that they may cause in the routing function if the metrics are not very stable. So I would think that this needs to be reviewed from a BGP perspective as well.
Great comment. Thank you for that. Yeah. Yeah. Tran, I think you have enough feedback on the stateful thing from John and also from Ketan that this has some routing implications. We need to, we may want to run it in the other group and see based on that, if there's a mobility implication, we can do some things here. Does that work?
Yes, I agree.
Thank you so much. I think just to summarize, I think, we have today, I think we made progress on 3 or 4 documents. We should be able to at least, on the SRv6.1, on the Marcos and John's, we can completed the work. I think 3 or 4 documents, we should be able to either issue adoption call or go to the next steps. I think that's where we are. Satoru-san, any final thoughts?
For you? Yes.
Okay. With that, we close this meeting. Thank you all for coming to joining the meeting. I think the meeting notes, TNG. Okay. Thank you. Thank you. Okay. Thank you. One more great meeting. Great. Good feedback. Multiple things.